Hello, I want to talk about the video streaming platform, system design interview question. So it talks about systems like Twitch or streaming on YouTube. So let's go through the topics. First one is, as always, clarifying questions and requirements. Second, typical one, high-level components. I'll talk more about object storage and what we need from it. Then transcoding workflow, and then VOD aggregator and compressor. Doesn't cover everything you can talk about, but hopefully gives enough of information to go through the main parts. So clarifying questions, what functionality is supported besides streaming and watching? Do we have VODs? Probably yes. Accounts, chat, payment system. It can get very complicated and pretty much involve several different systems. I guess for now, for simplicity, we'll only include VODs out of this list. Then, what are supported video resolutions? Or only original, or do we transcode to various qualities? We'll probably wanna discover how to do transcoding of a sort, because if you're streaming in 1440p, then not everybody has the internet to watch you, with the big capacity. So maybe they wanna 1080p or 720p. Maybe they have limited amount of data they can get in the months. So transcoding is pretty important. What's acceptable latency? 1, 5 seconds, or 30 seconds. We'll go somewhere between 1 to 5 seconds. It's hard to guarantee a very exact one. There may be some delays in streaming, and then you need to some trade-offs between do you lose some frames, or do you just delay until you retry it a couple times? But I think up to 5 seconds should be generally good. That's what seems offered by those platforms in default mode. Then, can anybody in the internet watch streams without logging in, or do they need an account? That's an interesting question. For now, we'll probably say that, okay, anybody can watch, as we're not going to cover accounts. But if you would go into chat, etc., and then accounts becomes pretty important to cover. Then how long is the VOD stored for? That's important for some numerical estimations for the cost of the system. And typically, I think Twitch stores for them for 14 days. But then if you do highlight, it can be 60 days. But if you have some partnership and maybe some pay them, then you can store them for longer. How many viewers and streamers do we expect? Again, it depends. Depends whom you're interviewing for. Some smaller company, some maybe startup, they can offer you smaller numbers to match what they have. Big company may offer you something 100 million viewers, maybe 1 million streamers or something like that. So check with the interviewer and just see what they say. But for this question, there's not going to be much difference in how we approach the problem. But if you're gonna talk into detail how you for example, do object storage, and if the interviewer wants to see some details of that part, maybe that's gonna be more relevant. But then again, things like object storage, they of complexity of a separate interview pretty much. So it's unlikely there's gonna be a lot of depth covered there. So let's go to high-level components. So there are 3 parts to it. One is how we record stream. So there is a client, something like OBS, which connects to your servers, and then go through load balancer to API gateway, and then we can use some queue. So from queue we can put directly to object storage for raw data for lower latency. And then we can get to transcoder workflow, which is also gonna put to object storage, but chunks from different qualities. And then it also puts data to CDN for some at least popular streams. Then another one is watching. We're gonna try to get data from CDN. Content delivery networks can be pretty important and save a lot of bandwidth, a lot of server load. So definitely recommended to use them. Then Otherwise, other flow is just to go through load balancer, pay gateway, and go to the object storage directly. And some simple flow for like transcoding can look like, hey, we have a queue, we have a server to like access information about the workflows. We have a scheduler to like create jobs. We have a bunch of jobs. They can be running in separate pods, or they can be running on some like runners or like workers. There are multiple configurations how we can do it. They have different trade-offs. Runners are probably like have like lower latency to start a job. At the same time, they're harder to configure, and then you need to like adjust their capacity, for example, during the night or like during off-peak hours. That gets more complicated, but you can discuss it with your interviewer. You can start with like maybe jobs as separate pods and just say that, hey, there are trade-offs. And then jobs can do transcoding and they put information to object storage. And scheduler would take care of retries and like maybe marking things as like lost if the multiple retries failed. You can also put them in a dead letter queue for like later analysis, and maybe we can like recover it, at least for people who like watch VODs. So then for object storage, system to store binary blobs in a structured assembly and distributed file system. It can be like AWS S3 or HDFS. We really like append-only semantics here, which would be very useful for streaming because how the data is like coming in. And those systems often like use something like write-ahead log. So we would gonna be storing like some small chunks, maybe like for every second. We store like a video chunk and like metadata for this during streaming. And we need a lot of stuff: scalability, durability, availability, and performance, like retrieve data fast. But on a like 1 second, it's like latencies around like 1 second each, or maybe several seconds. S3, for example, should be able to like take care of this. Then let's talk about transcoding workflow. Here, the system like can resemble systems like temporal or temporal. So yeah, I'll go over this again. Like typically, we want some UI to analyze workflows and see like what failed, like check some logs. Sometimes we can just like directly look at the logs of systems like Kubernetes, but usually if we have like more like integrated UI and can do some manual operations like retries if necessary, or like reschedule, then it's gonna be pretty beneficial. Scheduler is needed. We can have separate pools, for example, for different resolutions. So maybe for like smaller resolutions, we process things faster. Jobs themselves, it's like presents a unit of work and like some scheduled instance of like doing this work. Yeah, we need some retry mechanisms. And then like for VOD aggregator and compressor, so streaming benefits from small chunks of videos, like maybe 1 second long for latency reasons. Like you don't want to wait until like you collect the full minute and only then to like show it to the person who like watches the video. However, for like VODs, it's gonna be more efficient to just store longer chunks because like metadata overhead would be big for like 1 second chunks, and like fragmentation can be like bigger for those like small chunks. And worse compression potentially can be the case because like you can potentially save on some transitions from like frame to frame, and when you start a new chunk, you start from scratch pretty much. A solution for this can be another workflow which gets historical video data either after the stream is over or after some delay, and combines short chunks into bigger ones and like deletes smaller ones and like stores the larger ones. And the users with historical streams would get these new larger chunks. And there may be some limitations on like what we store. So to avoid like huge videos, for example, YouTube streaming has limitation of like 12 hours. There are some exceptions, but they seem to be pretty rare, and like only a handful of like people can get them. So still, yeah, when you do like streaming, it's optimized for like real-time system, and for like storing videos, that's pretty much can be like a separate design question. Cool. Thanks for watching.